So our next topic of study is galactic interactions, how galaxies interact with each other. As I had said at the end of the previous set of slides, galaxies tend to be fairly close to each other, and therefore they interact with each other. Now let's put this into perspective. The Milky Way galaxy is hundreds of thousands of light years across, but the nearest galaxy is only a couple million light years away. So that's really only about 10 times the size of the galaxy. Put that into perspective in terms of stars. Stars are comparatively small. There's a huge amount of difference between stars and even planets in our own solar system. I mean, the sun. Take 10 times the size of the sun. That doesn't even get you to Mercury. And so stars are very small compared to the planetary systems. And distances. If you were to imagine, take the entire United States and imagine how big a star would be in compared, to scale. If you imagine a star about the size of a golf ball, then about 3 of them would fit in the United States. That's about how far apart stars are in our part of the galaxy. So they really don't run into each other very much. You can imagine galaxies, you got 3 golfers and they all each randomly hit golf balls somewhere in the United States. They're not likely to hit each other. But galaxies are different. Imagine the parking lot outside the PE building and science building. Not that we're parking at it this semester, but imagine back before we had to take the break for spring break and not come back because of the virus. Imagine that parking lot, and imagine that you had 25 cars in that parking lot, and then you blindfolded the drivers and they started driving. How likely would it be that those cars would start running into each other? And the answer is pretty likely. So that's kind of how this is. So galaxies are much more likely to run into each other. So stars tend to be very far apart and they move around. They randomly don't get close to each other. Galaxies, on the other hand, are pretty close by comparison. And so when they start moving around, it's very likely they run into each other. Some galaxies, you might have a small galaxy, another galaxy, and their gravity starts pulling and stretching on each other. Remember we talked about how a grand design spiral galaxy gets to be a grand design spiral, gravity interact. Well, that could be gravity of a small galaxy or gravity of a bigger galaxy a little bit further away. So galaxies can interact with each other, or they can even collide with each other. You can have a big galaxy colliding with a small galaxy. They can absorb each other. They can pass through each other. Remember, galaxies are mostly empty space, and so they can actually pass through each other, and the stars keep on going, but the interstellar medium gets ripped out as they do that. And so you can actually turn an SC galaxy into an SA, an SZ, or even an elliptical galaxy even, by stripping all the gas away from it, because then you stop the formation of stars. Here's an interesting group of galaxies right here. It's M81 and M82. These are famous galaxies for amateur astronomers. They're located very close to the Big Dipper in the sky. And then there's NGC 3077, which is nearby. It's actually part of the same galaxy group. So if you look at these galaxies in the visual telescope, you see a very pretty grand design spiral. You see something here that's like fuzzy and weird looking, and then you see this one down here. Well, in radio telescopes, you see that M81, obviously spiral, but these other galaxies here have gas being pulled out and ripped out between them, so they're all interacting with each other. They're actually pulling gas out of each other, and so this group of galaxies has intergalactic gas around it that's been pulled out all over the place by the gravitational interaction. But if you look at them up close, the gravity of this galaxy has stretched that, made it into a very pretty grand design spiral. The gravity of M81, though, has pulled on M82 and has squished it. When you squish it, then what happens is the interstellar medium all exceeds Jeans criterion, and when it exceeds Jeans criterion, then all of a sudden you have this huge blast of stars being made all at once. And so we call that a starburst galaxy. Well, the problem with a starburst is that all these stars tend to die all at once. If you have a whole bunch of really high mass stars being formed at once, you start having a whole bunch of supernovae. And so in the past, not too terribly distant past, there were a whole bunch of supernovae in M82, and all these supernovae going off in M82 have been pushing the interstellar medium out. So it's like vomiting interstellar medium into space. So this is something that's not really a spiral galaxy anymore because it's being disrupted. It's definitely not an elliptical galaxy because you've got all this dust and gas. So this would be an irregular galaxy. This is one of the galaxies that you classified. Galaxies can also run into each other. A big galaxy and a small galaxy running into each other. The small galaxy is ripped apart and merges with the big galaxy. And that would be galactic cannibalism. So here we have a big galaxy right here eating a smaller galaxy. There's evidence that the Andromeda Galaxy has done this. There's evidence that when you look at it in the infrared, that we have this warped disk of dust in there that is warped by a collision with something smaller in the distant past. In fact, if you look at the core of the Andromeda Galaxy in visual light, you can see a very tight core in the middle. Well, we expect that for a supermassive black hole, but the Hubble telescope actually shows that it's a double core. We have the bright core, which is the main core, and we have a smaller thing orbiting around it. Well, where did the small one come from? Well, it's like a small supermassive black hole. I know that sounds weird, but a small supermassive black hole. Where did that come from? Well, it would come from a small galaxy that got eaten by the big galaxy. And so this gives rise to the idea, in fact, that this can happen. In fact, we do know from looking at the gravitational wave stuff that we had when we talk about black holes, that these big black holes can merge with each other. Okay, so again, we look at our own galaxy, and there's swarms of gas and stars swirling around, mixing with the rest of our galaxy, indicating that in fact we too are eating our companion galaxies. Even the Magellanic Clouds, we're streaming all this stuff behind them. That's slowing them down. They're spiraling into our galaxy, so they're going to be eaten in the future. Indications are from the speed of them, this may be with their first close pass to us, because it looks like they're not going to survive more than a couple passes by. So with galaxy collisions, they happen way more often than, for example, star collisions. When galaxies collide, interesting things can happen. How fast they collide really matters. If you have spiral galaxies that are coming together really fast, they pass through each other and they just strip away the interstellar medium. But if spiral galaxies collide slowly, then what happens is they swirl around and they merge, and as they do, the gravity starts ripping and pushing stuff out. So they merge into something, but they spew a bunch of stuff out in the collision process. This is an example of a galaxy. This is kind of a cool picture. This is a really rare sort of collision in which you had a spiral galaxy and some little small thing went shooting through the middle of it and created a shock wave in the interstellar medium, causing star formation. And then the shock also made the interstellar medium, the little small galaxy, all clump up and star formation. So this is a starburst. Ignore that thing there. That's a background galaxy. It's not part of the system. There's another really pretty case of merging galaxies right here. Here we have galaxies that are merging, and so there are two spiral galaxies merging slowly, and then as the gas is being pulled in by that one, it's thrown out. The gas from this one's being thrown out that way, and so we can actually simulate this with computers, and have a computer keep track of a whole bunch of things swirling around two cores. As they come together, they merge and throw stuff out all over the place. And so that's exactly what we see when we look at these two colliding galaxies. That's just an artist impression about what it would look like, for example, with with the cartwheel. Um, Speaking of colliding galaxies, remember I said that in a distant interaction between the Andromeda Galaxy and possibly Dwingler 1, it slowed down. It's falling towards us. So as it's falling towards us, the Andromeda Galaxy is eventually going to run into our galaxy. So the Andromeda Galaxy M31 is on a collision course. It's going to be about 4 billion years, give or take a billion years. Now it's a give or take because it'd be less than 4 billion years before the two outermost parts, the coronas, run into each other. It would be maybe about 4 billion years until the outer parts of the galaxies run into each other, and then about 5 billion years before the disks of the galaxies start merging. And so that's why, because they're not solid objects, and so that's why there's some ambiguity as to when the collision happens. They are moving together slowly enough. They will merge. And then M33, another spiral galaxy that's near the Andromeda Galaxy, will start orbiting the big remnant, and then it will eventually merge with the Milky Way too. So right now we got the Milky Way and the Andromeda Galaxy way off in the distance. In the distant future, it's going to be very big in the sky. So the Milky Way running across this, the Andromeda Galaxy like that in the sky, and then it's going to start running into it, and then start causing interstellar medium to exceed Jeans criteria, starburst regions all over our galaxy, lots of new star formation, things like the Orion Nebula everywhere in the sky, and eventually it disrupts the interstellar medium, so you might be able to see the two cores of the two galaxies. Now, what happens next depends on who you ask. Sometimes they look at it and say, well, the sun is going to end up orbiting far away from the cores. Other models show the sun being kicked out of the system into intergalactic space. And then some show the sun diving in between the cores, in which case we get a really cool view of the supermassive black hole and accretion and a jet coming out of it. Well, sort of a cool view would be fried by the radiation. So, I mean, it might be a cool view, but we wouldn't be able to watch it. Okay, so again, computer simulations of what a collision between two similar sized spiral galaxies will look like. Some stuff getting kicked out and then forming a new thing in the end. So, which raises an interesting thing. If galaxies can collide and kick gas out, that could, in principle, create spiral galaxies. Take spiral galaxies and cause them to create elliptical galaxies. So we'll get back to that in our next, we'll get back to that in our very next lecture.